Well, we'll wait till quantum really comes around in the mainstream before we expect it to go. Good morning, good afternoon, good evening. This is Chris Hewer at Web 3.1 asking the question, what will it take to deliver on the promise of Web 3? Really excited today to be joined by Tina Hui, my co-host, and Bram Cohen, the founder of BitTorrent and the founder CEO of Chia. We're going to talk a little bit more about Chia, but really get into the mind of a visionary and what he's been looking at as to what we need and what's next. And Tina, you know all too well what Bram's been up to over all these years. We've been fortunate to hang out in a lot of the same circles in Silicon Valley, San Francisco. And if I recall correctly, I think he came up to you at one point and said, I'm thinking about doing a blockchain sort of thing and reinventing it. So why don't you go ahead and take it away and lead our way through this conversation with Bram?
Actually, Bram, it's really great to have you on the show and obviously be friends for so many years and see the evolution of our discussions with Bitcoin. Little do people know, we actually filmed some footage with Bram in the early days for asking him what he thought about Bitcoin. And the evolution was very different and interesting. And it was fun to walk that through with you to see exactly how you started seeing some of the problems that were occurring and some of the solutions, and then now you founded Chia, and it's pretty exciting watching you constantly build on Chia. And to give people background a little bit, if you don't know Bram, he actually was the author and founder of BitTorrent protocol, which was the most used protocol for peer-to-peer file sharing over the internet in 2009. But it's really exciting to have you here, and I'm just curious. Yes, we've been following and learning about Chia with you, and I think you're the mastermind. Can you please tell us how things have been going, what you've been working on, and like also how's Chia doing?
Oh, well, Chia launched a year ago, so we've had a coin up and running. Yeah, it's Chia is based on proofs of space and time, and with space mostly being the hero of the show, so that it's got over 30 exabytes of net space behind it now. So it's very secure and there's very little electricity being burned doing it. That's the whole point, just use space, but without using lots of electricity. So it's greener and more distributed as a cryptocurrency. So those are really great properties for it to have. Also has a really good on-chain programming environment where we are in the process of building out functionality and showing how it can be done. So we just, well, not just anymore. We did release our asset token standard. So you can do the equivalent of like ERC20 tokens on it. But much more powerful in that the Chia cats, that's what we call Chia asset tokens. You can actually have smart coin functionality in cats. We're in the process of building up examples of that to show people. We also released our decentralized exchange of it. So if one person wants to exchange some amount of a cat for some amount of vanilla Chia, they can just make an offer file, send it to somebody else. That person can finish it, put it on chain, and then the trade goes through atomically, where the parties involved are guaranteed that they won't get ripped off in the process of doing it. So in fact, it's even possible to market make. You can take a bunch of people's offers and collate them together and have a price that's met in the middle through all of them. So really taking a lot of the things that blockchains are actually good for in terms of price discovery and for making very, very liquid, transparent markets and making that happen. And so we're in the process of building out AMMs from here and improving custody solutions. I'm working on that. And yeah, we're going to do some we're going to release an NFT standard and do some on-chain gaming. So a whole lot of things coming up.
As a creator in the space, I'm always curious when you see the pros and cons of something in the present day, how do you kind of start unraveling and studying how to build things differently? And then I know you've done a lot of this in Chia. What would be the difference between a Chia NFT process and a blockchain process?
Well, Chia has blockchains, but if you're comparing Chia to like Ethereum, a big feature that we're offering for Chia NFTs is the feature that there's a payment back to the original issuer whenever they change hands is actually enforced on chain. So it's not, you don't have to rely on exchanges to kind of do that for you. The NFT itself enforces that it will refuse to change hands until the old owner and the new owner both inform it that it should change hands and give it the same price as what's being used for it changing hands. And then it sends back up.
Yeah, that's huge because people are being scammed from that intermediary process, which is terrible. And that brings me to kind of the bigger question lately is there's a lot going on in terms of looking at what can be improved. And so while we're here at the Web3 conference, I'm curious what you see other like yourself and other people who are trying to build on the technology. What can be done to kind of build better? Is it these custodial, you know?
Oh, well, there's a lot of things that can be done better. The engineering in the space is not very good in general. The programming environment we have on Chia, it's based off of Lisp and has very, very simple on-chain data structures. It's really designed from the ground up for auditability and security as like a central thing. But on top of that, it also has tremendous extensibility in that it turns out in on-chain programming, you really want to call eval a lot. It's like really normal that somebody sends you a piece of code, you validate the integrity of that piece of code, and then you call it even though you don't really trust it. So in programming environments that aren't designed for sandboxing, it's really a nightmare to try to get this working. So we just made it so that everything is no side effects everywhere. And hence this particular thing that we're doing. But there are tricks in this where you can actually have like our arbitrary size data essentially stored on chain, although it itself is not on chain, it's committed to on chain. And also have capabilities on chain, like something being a valid asset token that actually does represent that amount of that underlying asset.
I had to ask you because you know all about the dev and tech stacks, and you could probably you build.
EVM is really kind of a hack job. I mean, they didn't know any, like, not like they could have done any better under the circumstances, but it's really kind of throw a whole bunch of mud at the wall and hope something sticks, like make a general purpose environment that can do whatever, and you'll be able to do stuff in it. And it does do that. But it's really not what you want for on-chain programming. For on-chain programming involving like real money, you want things that are extremely auditable, secure, reliable, and where everything can interoperate and everything can be extended. And yeah, you get these not infrequent massive hacks where quite a bit of money is stolen. Yeah, that happens in major ways. And the on-chain programming environment not really being up to the task is a big part of that being done. There's also some fault of the software development processes going on top of it as well, but definitely the environment can be improved. The one thing that Solidity does have going for it is it's designed so that a web developer can get up and running and get something that kind of looks like it's working in an afternoon, which when it comes to banking applications might be a bad thing.
Now, Bram, you talked about it not being stored on chain in some portions or some of it not being. And of course, one of the things a lot of developers praise is the ability of decentralization to lead the way. Do you believe that decentralization has to happen, or is it really going to be a hybrid?
When I talk about things not being stored on chain, what I mean is you can have them be committed to on chain without being stored on chain. So there's some data structure that's being communicated off chain, but it's being committed to on chain. So like one of the things we're working on is a data layer where someone's just reporting a data set on chain, and people kind of trust them. And this leads to a bunch of neat pieces of functionality where whoever's reporting this is making the whole data set available elsewhere, so people can actually use it. But the offers functionality can apply here, that someone can commit some funds on chain to say, if this data layer thing gets updated to have this particular piece of information in it, then you can claim these funds. So that way, if there's some real world asset that's being tracked by a certain thing, and I want to buy it from you, I can purchase it from you in that way, where we only have to kind of lightly trust this third party to accurately report who the current owner is, and they don't have to get involved in our transaction directly.
Which would be safer all around.
Yeah.
Way safer. I wish it was that way now, right?
Yeah, well, the blockchain itself, it doesn't have a huge amount of capacity for storing data. Really, security on the blockchain is turned up to 11, and there's good reasons for that. And you're paying for that every time you put something on the blockchain. So you want to make it so that the data is committed to. There's what's called a Merkle root that references everything. You can show it there, but you only have to do reveals to the actual thing when it's actually used.
Now, before Tina goes on to the next kind of big topic area for you, I did want to ask a little bit more if you could explain the differences between proof of space and proof of work and proof of stake. A lot of people have been hearing about proof of stake and Ethereum supposedly moving in that direction with the new updates and the next rev to be able to make it a little more environmentally friendly, hopefully reduce the cost somewhat. But proof of space, I don't know that I necessarily get that yet.
Yeah, proof of space is pretty close to proof of work. It's Nakamoto consensus. So the big innovation with Bitcoin was Nakamoto consensus. There's how do we make a truly decentralized database? So there were people had been working on decentralized databases before that, but their level of decentralization wasn't very good. It was the level of a decentralization you have of proof of stake right now, which is there's a bunch of people who control it. And if they decide they want to keep controlling it, they can keep controlling it forever. And the only way to get any control of it is to pay someone who has some amount of control for it, and you have to get it from them. Right? You don't have this property that anyone can just join and anyone could just leave and the whole thing just chugs along just fine no matter what, which is what you really want to have happen. So, so Satoshi Nakamoto had an idea, had a wonderful, horrible idea, which was here's what we'll do. We'll make it so that there's a data structure that had a certain amount of blood, sweat, and tears that went into generating it. You can verify that this actual work went into generating it by it having partial hash collisions, dead beefs. And anyone can verify it. And if you and I get into a discussion of what is the current state of this thing, we just compare whose version has more weight, and the one with greater weight wins. And generally speaking, people just pile on top, right? Which leads to this question of, well, oh, okay, well, that's nice and all, but how do we get people to do that work? How do we get people to build on it? And the answer is, well, we'll make it so that the database itself is a database of money, and it pays people to mine it. It pays people to extend it out of the money that it itself keeps track of, and those are the rules. That's how it's going to work. So this works. It has limitations. Kind of all the data is going everywhere, so the throughput of the database is not huge, and it involves warehouses full of computers, burning electricity, doing not much of anything. This is not what Satoshi hoped for. He wrote in the white paper about how maybe he said one IP address, one vote doesn't work, but maybe one CPU, one vote works, and clearly had this idea that mining would mostly be a matter of utilizing CPUs that are mostly sitting around doing not much of anything. And so this is like a sunk cost that you're tapping into here, which of course is not how it's panned out. that simply is not competitive. In practice, Bitcoin mining is all custom hardware, burning massive quantities of electricity in this extremely wasteful process with quite a bit of economies of scale that go to it. So you want to do better than that. And ideally, what you would like is to have some resource where you can't make special hardware for it, and that's already massively over provisioned out in the world. So you are tapping into this resource. You're doing Satoshi's vision. You're doing what Satoshi wanted to do. And it turns out it's very hard to do this because it needs to be something, well, totally commodity, and it needs to be something where not only do you not need extra computational capabilities in order to get ahead, but you can't use extra computational capabilities to get ahead. Like that's not even available to you as an approach, no matter how clever you are. That's very hard to do, but it turns out there is an appropriate resource, which is storage capacity. Storage capacity is great. It's bytes everywhere. It's all bytes. The API doesn't change anywhere. If you want to make an ASIC of storage, we have those. They're called SSDs. It's all, and there's a long list of highly technical issues with making it so that you can't get ahead using more CPU. It turns out a critical part of this is throwing in proofs of time, what are called verifiable delay functions. You have these interesting entities called time lords that are out there on the internet doing their time lording thing.
Yay, Whovians.
Yeah. So that's why it's proofs of space and time. But intentionally by design, the time lords they're all doing the same thing. If the fastest one went away, the second fastest one would just be doing the exact same thing, just a little bit slower. So really the proofs of space are the heroes of the show here. So that makes it, because there's so much of this already out there in the world, it's already pretty widely distributed, and this will be getting better in the future. This space is not being tapped into super well yet. There's lots of hard drives that are getting thrown out all the time, and there's lots of storage capacity that's over provisioned and ready to be used in the future and not getting used yet. So those resources can be used for farming going forwards.
Gotcha. So if I can synthesize and make sure that I kind of get the basics here. So space becomes the stand-in for the stake in one case, and for the other one, for the voting or for the mechanism for figuring out the computation for the algorithm for the hash. Is that right?
Yeah. Well, it's
and then the time creates sort of other.
Yeah, if you want to analogize between them, with space, you have farms which have space on them, but you could do it on your own computer. You have extra space there. You could go make some plots and start earning some number of pennies per day off of farming Chia off of it. It's just storage capacity that you have in Chia. The equivalent thing in like Bitcoin is you have these like ant miners and stuff. You have these ASICs that are these custom pieces of hardware that are burning quite a bit of electricity, where obviously your drive on your computer is sitting around not doing much of anything. And then the equivalent in proof of stake is just the stake that you have. But proof of stake is not really comparable because it doesn't provide the same kind of security guarantees at all.
Gotcha. So we have increased security, decreased costs, decreased ability to gamify and seize control. So really delivering on greater decentralization, and then a more higher transaction volume that you can put through as well. Is that correct?
Well, the transaction volume is part of the on-chain programming thing, and that's really orthogonal. Chia's practical transaction rate is higher, but not ludicrously higher. So when you talk about transactions, there's a question of how you measure it. But if you assume a reasonable standard transaction, Bitcoin can do about 5 of them per second, and Ethereum can do about 10 of them per second, and Chia can do about 20 of them per second when fully maxed out. That's just increasing some numbers and mostly just doing better engineering.
Well, we'll wait till quantum really comes around in the mainstream before we expect it to go.
The quantum computation doesn't do that. Chia mostly looks a lot like Bitcoin. That Bitcoin is in what's called the UTXO model, and Chia is basically it's in the CoinSet model. Almost everything in Chia looks like looks very overtly based off of Bitcoin, but just kind of rewritten from the ground up to be better, but taking all the fundamental concepts from there.
Awesome. That's what I wanted to make sure everyone understood as a takeaway from what you've been doing and why you've been doing it. Because how many years into Chia are you now?
Well, started working on it in 2017, but had been kind of noodling around the space and forming ideas before that. But there was still quite a bit of invent new math here on the product roadmap in 2017. There was like, it was literally like invent proofs of space, invent proofs of time, and figure out the subtle details of how to stitch them all together.
Well, I'm glad that you spent all that time to noodle and invent the new math, because now we have Chia, and it is the greener, I guess, chain. So I'm very personally pleased about it, since I'm very passionate about what's going on with the planet, and hopefully we could be less wasteful in total. And also, this, and I know this, and so does Chris, but it speaks to right now, Chia could become the more decentralized option because at the moment, with the way things are being mined, there's a lot of centralization going on. And how do we
Yeah,
actually
yeah.
talk about
The Bitcoin
decentralization?
mining operations do tend to be very large operations. It's not all that decentralized at all, and the pools are, even bigger. So yeah.
Yeah, and it's the number one energy consumption in some Eastern European country that I can't remember off the top of my head now.
Yeah, it's all pretty unpleasant that way.
Yeah. And that's part of the reason why we're having it, because being able to do this in a green way is a very important part of what's next as we look to put the next billion people into being able to trade value using these technologies.
Yeah, yeah. You don't want it to be getting worse as it gets, as it gets more people getting involved in it. And there's also things where, like, there's a lot of people who want to do like NFTs or places that want to issue carbon credits, and they don't want to do this on a blockchain. That's bad for the environment.
So what do you think we need to do from here, from where we are today, to move into 3.1 to really deliver on the promise?
Yeah, well, there's a lot of just building up infrastructure to get there. That for a lot of end users, not just like there being NFTs. NFTs are pretty neat, but to have things that actually matter for the web as a whole, it needs to scale to a huge number of people. And for that, you really need payment channel networks. And that needs to be integrated so that lots of people can get on these things in the first place. There's a lot of just real world infrastructure that has to happen for that to really get there. So that's going to be some amount of time for that to happen.
And could you give a little definition for those who don't know? What is a payment channel network and how is that different from a chain or some of these other elements?
Well, it's built on top of a blockchain, right? So when you have like banks, just banks in the regular banking industry, they don't send money to each other for every single transaction that happens. If you go to a corner store and buy a candy bar, it's not like there's a Fed wire for $1.25 that's that goes through. That would be ridiculous.
Yeah.
You have things that are happening and then it nets out between the vendor and the banks actually net out between each other and result in very few transactions actually going through on the back end of the whole thing, which is like the Fedwire system. Now, Fedwire looks an awful lot like a blockchain in terms of the transaction rate that's on it. And I think it's something like 40 transactions a second or something, amortized across everything. And then like the cost is like $20 a transaction or something. You get this very, it looks a lot like a blockchain. And a lot of the same thing carries over, that you want to do things via net settlement on a blockchain, just moving it off of Fedwire. Although I think there's a high probability that Fedwire at some point in the future will offer CLVM, that's the Chia virtual machine, as an API for doing things on that, because it's just a better way of doing things. Where they absolutely would not do that with the EVM, no way. But when banks are doing this, there's a lot of credit, like small amounts of credit going through the whole system. That's why they're called credit cards, right? And with cryptocurrencies, you really don't want to do that. You want to be settling out exactly the whole time. So instead, what you do is you make it so that people kind of post money beforehand, and then they're just kind of leaking it out over time. They're releasing bits of it as they do these transactions. And you net settle out in the end of the whole thing. That's what payment channel networks do. So you have a few transactions to get things started on chain, and only afterwards do you kind of sell them up. If someone finishes paying out everything or there's a problem, then you go to chain. But mostly you try to avoid having transactions on chain. And that makes it so transactions can go through like almost immediately, and it can scale to many, many more things.
So
Awesome.
thank you. What are you excited about in the space? What do you see 5-10 years from here? Since you're the visionary,
Well,
can you?
in terms of things I'm excited about, well, there's a bunch of neat stuff we're working on at Chia. We're working on NFTs. We're working on some on-chain gaming. We have asset tokens. We're working on getting things like carbon credits to be tokenized on-chain. and getting very liquid exchange of those going in terms of having AMMs and decentralized exchange and bringing real value there. That's a very good use of blockchains. Something that I'm very excited about that other people don't tend to get too excited about is better custody arrangements. I think, Bitcoin feels like carrying around suitcases full of $100 bills, and that's not how you want to do things. And when you use a bank, the bank is providing some custodial services to you. They're doing it in a way that is completely not transparent and that you have no control over whatsoever, but they are providing some kind of rate limiting and other types of services in control and recovery for your funds. And in blockchains have to date been worse for this. In principle, they should be able to be much better, that they have much better processes that the end user has complete control over and total transparency into. But people aren't excited about working on that, so they're not. So I'm excited about it because I think money should be secure. I don't like people's funds getting stolen. So I'm working on that right now. Thank you.